In this video, I am going to explain Dijkstra's algorithm, which is used to find out the shortest path between the source node and all other nodes within the graph. This one is a Dijkstra's algorithm. This Dijkstra's algorithm is used to find the shortest path between a given node, which is called source node, and all other nodes in the graph. This algorithm is used to find the shortest path between a given node which is called a source node, and all other nodes in the graph, and all other nodes in the graph. The elements present in the graph are called as nodes. The elements present in the graph are called as nodes. The connection between the nodes are called as edges. The connection between the nodes are called as edges. Suppose the example is nodes are represented by circles like that. These are connection. This is the graph. These are the nodes. Node 1, node 2, node 3, and node 4. These are the nodes. The connection between the nodes are called as edges. These are the edges of the graph. Assign weights to the edges. These are the weights which are assigned to these edges. Weight 2, weight 3, weight 4, and weight 5. The weight of the edge between 1 and 4 is 4. The weight of the edge 1 and 2 is 2. The weight of the edge 2 and 3 is 3. The weight of the edge 1 and 3 is 5, like that. So this algorithm use the weight of the edges. That means 2, 3, 5, 4, and so on, to find the path that minimize the total distance between source node and all other nodes. The main aim of that this Dijkstra's algorithm is to find out the shortest path between the given source node and all other remaining nodes within the graph. This algorithm uses the weights of the edges. And to find out and to find the path, that means shortest path distance shortest distance path that minimizes the total distance between source node and all other nodes. Source node and all other nodes. Here, this is the node 1 or node A. This is the node B. This is the node C. Node A and node B is connected by an edge. The weight of that this edge is AB edge is 2. The nodes A and C are connected by another edge. The weight of that one is 6. Initial assume A node as a source node. A node as a source node. The distance of that source node initially is 0. That means the distance between the source node and itself the source node, that is A, is 0. Here, the remaining B and C are two neighbor nodes. B and C are two neighbor nodes of A. Initially, we don't know the distance. We have to assign infinity distance to these nodes. That is dB is equal to infinity and d of C is equal to infinity. Therefore, weight of H A comma B is 2. Weight of H A comma C is 6. This algorithm uses the weight of the edges, that means 2 and 6. Find the path that minimize the total distance between source node and all other nodes. See the distance between A and B. The formula is distance of A node plus weight of AB, which is less than distance of B, which is less than B, distance of B. Therefore, this condition is satisfied. Distance of B is equal to distance of A plus beta. Okay. See this one. Find out dB. dA of AB is equal to distance of A is initially 0. This one is 0. Weight of that edge is AB edge is 2. 0 plus 2 is equal to 2. This is less than infinity because infinity means where distance of B. Distance of B node initially is infinity less than B. Therefore, this condition is satisfied. Therefore, dB is equal to dA plus WA of B. dA is equal to 2. dA is not 2. dA is 0. dA is 0. dA is 0 plus W of AB is 2. Therefore, dB is equal to distance of B node is 2. Distance of B node is 2. Therefore, infinity is strike off. Infinity is strike off and are replaced with dB is equal to 2. And in the similar fashion, you have to find out distance of C node. Now here distance between A and C node is equal to distance of A node plus weight of that edge A comma C is, which is less than T of C. We know distance of A, that is source node, 0. Weight A comma 6, A comma C is 6. A comma this one is C, not 6. 6 is less than, that is equal to is equal to 6 less than d of c. D of c value is infinity. Therefore, d of c is equal to d of a plus weight of a comma c. D of a is 0. Weight of a comma is that is 6. Therefore, infinity here, infinity is strike up, and d of c is equal to 6. After calculating these distances, d of neighbor node distances, and find out minimum distance node. Here, the distance from A to B is 2, A to C is 6. In that one, B is the minimum distance node from A node. Therefore, B node is acts as now B node is acts as working node. B node is acts as working node. In this fashion, you have to find out the shortest path between given source node and all other possible nodes within the given network. Next important point here is Dijkstra's algorithm is a single source shortest path algorithm. Next important point here is Dijkstra's algorithm is a single source shortest path algorithm. Shortest path algorithm. Here single source means here single source means that only source is given and we have to find out shortest path from the source to all other nodes. Single source means that only source is given, only source is given, and we have to find out, find the shortest path from the source to all other nodes in the graph. For a given graph, consider any one of the node as a source and assign distance values to all nodes in the graph. Here, consider any node in the graph as a source. Assign distance value to all nodes in the graph. Assign distance values to all nodes in the graph. Here some nodes are there here. This is the graph. The graphs are connected like that. One is here A, B, C, D, E, F, and G and H. The values 2, 1, 2, 2, 7, 4, 5, 2, 1, 2, 6 like that. Consider any node in the graph as a source. I think A node is the source node. The weight, assigned weight of that A node is dA is 0 initially. The distance from the source node to itself is 0. A node is the source node. The distance from the source node to itself, that means A to A. A to A is 0. That is the reason dA is 0. The source node will be a node, but it can be any node that we have chosen. Here in this graph, I choose A node as the source node, assign a distance value A is 0, and all other remaining nodes assign distance value to all nodes in the graph. All nodes in the graph means A node, I think A node is treated as source node, assign a distance is 0, and all other remaining nodes distances are infinity. We don't know the original distances initially at assign infinity distance. The distance from the source node to all other nodes has not been determined yet. That means initially the starting point is here. Initially the distance are not determined yet. That means assign infinity. So we use the infinity symbol to represent the node distances. That means infinity. So we use the infinity symbol to represent remaining nodes distances. The distance from the source node to all other nodes has not been determined yet. So we use the infinity symbol to represent the remaining node distances. That means dB of B is equal to infinity, dB of C is equal to infinity. Here, d of E is equal to infinity, d of H is equal to infinity, d of G is equal to infinity, d of D is equal to infinity, d of F is also infinity, like that. Only assign 0 distance to the source node is source node. That means in this example A is 0. Next important point is create a set that keep track of nodes is included in the shortest path. Initially, create a set. That means set means this one. Initially, the set is initially the set is empty. The set is empty. Create a set that keep track of nodes included in the shortest path. Included in the shortest path. Suppose A node is included, B node is included. Suppose here suppose this one is 6. Here distance is 2. That means 2, A. That means it indicates the distance between the distance from the A node is 2. Here B node situated here. The distance from the A node is 2. their previous node is A node. Here, here H node, the distance from that H node to A node is 6. Previous node is A node. This one is 6, A. This one is 2, A. In this fashion, you have to find out the distances. Okay, now in this path, this H node is not chosen because the value is 6. B node is chosen because the value is 2. 2 is less than 6. Therefore, in that path, A node and the B node is included. That means the set includes A, B, and so on. In this fashion, we have to determine the shortest path between the nodes, between the source node and the remaining all other nodes. Create a set that keep track of nodes included in the shortest path. These are the nodes A, B. The set does not include all the nodes in the graph. Only few nodes are included in that set. The set does not include all nodes of the graph. Okay. Next one is next important point here is suppose pick up a node from the graph. Pick up a node K, which is initially not there, in the shortest path, which is not there in shortest path, and I have a minimum distance value, and I have a minimum distance value. That means here A, here B, here C, or else A is equal to K. Pick up a node K. Pick up a node means here K. Pick up a node K, which is not there in shortest path, and have a minimum distance value. That means A to K edge, A to L 6. That means 2, A, 6, A. This is the minimum distance value. 2 is the K is the minimum distance. K is placed here. The distance between K and A is 2. Okay, that is called as minimum distance value. Okay, na? Okay. After that, include K in shortest path. Include K in shortest path. Include K in shortest path. The neighbor nodes of A are K and L. Update the distance values of all adjacent nodes of A. That means how to update the distance values of all the adjacent nodes. That is then update the distance values of all adjacent nodes of A. Adjacent nodes of A. That is, we know that this is the source node. Initial distance of source node is 0. That is distance between A and K is D of A. Weight of A, K is less than D of K. Okay, initially initially the distance of these two nodes k and l is infinity. D of a is 0. Weight of a comma k is 2 less than d of k, that is equal to infinity. Okay, therefore that is 2 less than infinity. Therefore d of k is equal to d of a plus weight of a comma k. D of k is 0, weight of a comma k is 2. Therefore d of k is 2. The update distance values of all adjacent nodes of k in this fashion. Here k and L are two adjacent nodes. Next, d of a comma L, that is distance of a node, weight of a comma L less than d of L. D of a is 0, weight a comma L is 6 less than d of L, that is equal to infinity. Therefore d of L is equal to d of a comma weight of a comma L. D of a is 0, weight that is 6. D of L is equal to 6. This is the update the distance values of all adjacent nodes of A. To update the distance values, iterate through all adjacent nodes of the graph. So many nodes are there within the graph. Have to update all the distance values of the remaining nodes within the graph by using iterative procedure. To update the distance values, iterate through all adjacent nodes of the graph. In this fashion, we have to determine the shortest path between source node and all possible nodes which are available in the graph. Generally, this is the U is the source node, B is the destination node, neighbor node. Okay, D of U is equal to 0. Find out initially have to assign infinity here 0. Edge of that UV is that is equal to 4. That is weight of these two nodes U and V nodes are connected by an edges. The weight of that edge U comma V is 4. Assigned here some metric. Find out the D of V. Find out the distance between U and V is equal to D of U plus weight of U comma V less than D of V. D of U is 0, weight is 4 less than D of V is initially infinity. Therefore 4 is less than infinity. In that case, the distance of dV is equal to D of U plus U of W of U of V. W of U of V. D of U is 0. W of U of V is 4. Therefore, dV is equal to 4. Infinity strike off. Therefore, the distance of V node is replaced with 4. In this fashion, you have to calculate all other nodes distances from the source node. With this algorithm concept is completed. If you like this video, please subscribe the channel for further updates. Thank you.